Hello students. Today in this lecture we will be studying integers and whole numbers. So integers and whole numbers are very basic type of numbers. We all know that from ancient times humans used numbers to quantify things so that they could compare stuffs like animals, objects. They can compare using numbers. So and the topic integers and whole numbers plays a very crucial role in cracking various competitive exams. So, we'll explore this topic today. So, we'll be covering concepts and types of problems on integers and whole numbers. So, numbers are actually special words that used to count things or to quantify amounts. So, if you want to quantify stuffs, like let's say if Anup has toys and Saloni has toys, so how can you say that who has more toys? Anup has more toys or Saloni has more toys. So if Anup has two toys and Saloni have three toys, then we can say that Saloni have more toys. So that's why we need numbers to quantify things and to compare objects, number of objects. Okay. So how numbers are divided in general? There are three types of numbers: natural numbers, whole numbers, and integers. Let's explore each one. What is natural number, what is whole number, and what are integers. Okay. Natural number is nothing but the numbers that occur naturally, like 1, 2, 3, and so on. And whole numbers are nothing but an extension of natural numbers, including 0, 1, 2, 3, and so on. So you can see that 0 is nothing but just addition to the natural numbers. And we all know that how 0 is important. So what are integers? Integers are nothing but the whole numbers 0, 1, 2, 3, 4, and so on, and the negative numbers, that is -1, -2, -3, -4, and so on. So natural numbers are 1, 2, 3, and so on, and whole numbers are nothing but an extension of natural numbers. That is, what we did was just added 0 to it. Okay. So integers are what? Integers are whole numbers, but with their negative counterparts. Okay. Like here we have 0, 1, 2, 3, and 4, but we had their negative counterparts like -1, -2, -3, and -4 there. Okay. And so on. For each natural number, there will be a negative counterpart of it available in the integers. Okay. So let's explore each one. So natural numbers are special numbers that are used to count things, okay, that occur naturally. When you see goats, so what do you see? Like two goats, three goats. Have you ever saw like zero goat or -2 goats? No, right? That's why natural numbers are special number for counting things that occur naturally. Okay. So what are whole numbers? Whole numbers include all natural numbers and 0, as we explored. Here you can see that 0 is included here, and these are the natural numbers. And here is 0. Okay. So this is the whole number set. Okay. Whole number is nothing but an extension of natural number. What kind of extension? Only the number 0 added to it. Okay. So let's explore what are integers. So integers are a set of numbers that include both positive numbers and negative numbers. Okay. As I have told earlier, here you can see that 0 from whole number extension, we got that 0, and these are natural numbers 1, 2, 3, and we have their negative counterparts, right? -1, -2, and -3, and so on. Okay. So integers are nothing but an extension of whole number. What kind of extension? That we have the negative counterparts of all the natural numbers present in the whole number set. Okay, that is integers. Now let's explore the types of integers, right? There are positive integers, there are negative integers, and there is zero integer. Zero integer is nothing but the number zero. Okay, and what are negative integers and what are positive integers? Let's see. So positive integers are nothing but like 1, 2, 3, 4, and so on. This is nothing but the natural set, natural number set. Okay, these two are same, and its negative counterpart is negative integers like -1, -2, -3, -4, and so on. This set is called negative integer, and the natural number set is also called a positive integer, and zero integer is nothing but the number 0. So positive integers are whole numbers greater than 0. They are denoted by the natural numbers. We all, yeah. Okay. So this is nothing but the natural number set, and negative integers are nothing but the negative counterpart of the natural number set. This is the negative counterpart like -1, -2, -3, -4, and so on. Okay, and these are nothing but the whole numbers that are less than 0. Okay, and you can see the, in order to showcase the negative counterpart, we have used the negative sign. Okay, yeah, you can see this. Yeah. So, and the 0 is a unique integer that has neither positive value or negative value. So it is represented as 0. So 0 serves as the origin of natural number line and is vital in various mathematical operations and concepts. So let's explore the properties of integers. So what kind of properties do integer possess? So there is closure property of addition and multiplication. Okay, we'll explore each one. Okay, so closure property of addition and multiplication, commutative property of addition and multiplication, associative property of addition and multiplication, and identity element, what is inverse element of addition and multiplication. We'll see each one. Okay, and what is distributive property, we will see each one. Let's explore the closure property of addition and multiplication. So what is addition? When we add two numbers, two integers, the result is always an integer. So if a is an integer, okay, if a belongs to integers and b also belongs to integers, then c also belongs to integer. For example, here we can see that if we add 1 plus 2, then we'll get 3. You all know that 1 belongs to integer, 2 belongs to integer, and 3 also belongs to integer. Okay, so the closure property of addition and multiplication. So let's see the multiplication part. So when you multiply two integers, the result is always an integer. So if we multiply 1 with 2, okay, what we get? We get 2. This belongs to integer set, this belongs to integer set, and this also belongs to integer set. So the multiplication, closure property of multiplication holds for integers. Okay, we can see that from here. Okay, let's explore the second property, that is the commutative property of addition. So if we add two integers, okay, a belongs to integer and integer set and b belongs to integer set, then b plus a is equal to a plus b. Okay, so changing the order of adding integers does not affect the sum. For example, you can see here 1 plus 2 is equal to 2 plus 1. Why? This is equal to 3 and this is also equal to 3. So we can say that both are same. Okay, so let's see the part where the commutative property of multiplication comes. So commutative property of multiplication, changing the order of multiplying integers does not affect the product. So if we multiply 1 with 2, then what we get? We get 2. And if we multiply 2 with 1, what we get? We get 2. These are same. So I have took an example here, but it holds for all the integers. Okay. Like if we take 33 into 33, 33, 34, then it is equal to 34 into 33, as these two both belong to integers, or these are integers. So let's see the associative property of addition. The grouping of 3 or more integers being added does not affect the sum. So for example, you can see here 1 plus 3 plus 7 is equal to 7 plus 3 is equal to this is equal to 4 plus 7, this is equal to 11, right? And here we can see that 1 plus 3 plus 7 is equal to 1 plus 10, this is equal to 11. So these two are same, right? So that's how we can say that the grouping of 3 or more integers being added does not actually affect the sum, and we say that the associative property for addition holds. Let's see the multiplication part for the associative property. Okay, so just like that, we can see that 3 into 4 into 2, what is it equal to? This is equal to 3 into 4 is equal to 12 into 2 is equal to 24. Let's see this part is equal to 24 or not. So 3 into 4 into 2, right? So this is equal to 3 into 8. This is equal to 24. So we can see that these two are same. Okay. So the associative property of multiplication holds. So the identity element of addition. Let's see what is the identity element of addition. So the identity element for addition is 0. Okay. In the whole number set, what we discovered that in whole number we got 0, 1, 2, 3, 4, and so on. Right? We got 0 in there. So in the whole number set, we saw that we got 0 in there with the all the natural numbers. So the 0 we got there is actually the identity element for addition. Okay, addition. How? Let's see. So here, if a is an integer, then plus 0 is that integer exactly. Okay. Okay. So for integer example, we get, let's say we take 3 and we add 0 to it. Okay. So what we will get? We'll get 3, right? So that is why 3 is the identity element of addition. Okay. We won't get 3 if we multiply 0 with it. Okay. 3 into 0 is not equal to 3. That's why 0 is not an identity element of multiplication. Okay. This is not possible. So this is possible. So let's see the identity element of multiplication. We saw that 0 was the identity element of addition, right? So now we'll explore the identity element for multiplication. Okay, this shouldn't be surprising. The identity element for multiplication is 1. So 1 is the identity element for multiplication. Okay, so multiplying an integer by 1 gives the same integer. Like for example, here we can take 7 into 1 is equal to 7. We never got 7 into 0 is equal to 7, right? So this is not possible. So this is how 1 is the identity element of multiplication. Okay. So 1 is the identity element of multiplication. So 0 is identity element for addition, and 1 is identity element for multiplication. Okay, let's go through the fifth property of integer, that is inverse element of addition. So the additive inverse of an integer a is minus a. So if 1 is an integer, then its additive inverse is nothing but minus 1. Okay, so here a is 1 and minus a is minus 1, as 1 plus minus 1 is equal to 0. Okay, so additive inverse of a is minus a, that's why additive inverse of 1 is minus 1. Like this, we can see that for each natural number we can get a additive inverse. Okay, like for 2 we can get that minus 2 is equal to 0, 3 plus minus 3 is equal to 0. That's how we can get, for each natural number we can get a additive inverse. Okay, in the natural number set. Okay, so let's explore the sixth property of integers. So the distributive property of integers. Okay, this is a very crucial property. So the distributive property states that the multiplication of an integer a with the sum of two integers b. Okay, here you can see that the multiplication of an integer a, okay, with the sum of two integers b and c. Here you can say that multiplication of a with the sum of b plus c. Here we have two integers, okay, b and c. We summed them and then we multiplied with a, is actually equal to a multiplied by b and added to a multiplied with c individually. Okay, these two are multiplied separately. Okay, here you can see that a is multiplied with the addition of b plus c. Okay, first b was added with c, then it was multiplied with a. That is actually equal to a multiplied by b plus a multiplied by c. That we multiply a with b individually and a with c separately, then we add these two, we will get the same here. Okay, let's see an example. So for example, if we multiply 1 with 2 plus 3, what we will get? We will get 2 plus 3 is equal to 5, multiplied by 1 we will get 5. Okay, and if we do the same here, that is 1 multiplied by 2 plus 1 multiplied by 3, what do we get? We will get 2 plus 3, that is equal to 5. So you can see that we are getting the same number 5. So we can see that the distributive property holds here. You may say that I used 1. Okay, so let's see this with another example. Okay, so 2 into 3 plus 5, let's say. Okay, this is actually equal to 2 into 3 plus 5 is equal to 8, so this is equal to 16. So let's see how the right hand side of this will look like. So 2 multiplied by 3 plus 2 multiplied by 5. So this is equal to 6 and this is equal to 10, that is equal to 16. Okay, so we can see that these two are same. So we can say that the distributive property holds. Okay, so let's go through all the properties again so that we could get our heads around it. So the first property told us that the closure property of addition and multiplication. For addition, if we get two integers and we add them, we'll get an integer. Okay. And the second property, that is the closure property for multiplication, told us that if a and b are integers, c will also be an integer. That is 1 into 2 is equal to 2, that belongs to integer. Okay. So we can see that if we multiply two integers, we'll get another integer. Okay. That's what the closure property tells us. So the commutative property of addition. Okay. The commutative property of addition tells us that if a is added to b, then b is added to a are the same. Okay. If we add 1 plus 2, then it is actually equal to 2 plus 1. Changing the order does not affect the sum. Okay. So 3 plus 4 is equal to 4 plus 3, and so on. We can get many examples for it. Okay. So the multiplication counterpart for the commutative property is if we multiply two integers, what we will get is the same. So the multiplicative counterpart for the commutative property, what it tells us is if we multiply two integers, a into b, and we multiply b into a, they are nothing but same. Okay, they are nothing different, they are same. Here you can see that 1 into 2 is equal to 2 into 1, so 2 is equal to 2. So another example was 33 into 34 is equal to 34 into 33. Okay, so we can go to the next property, that is associative property of addition. So what it told us was if we add three integers, that is we add two integers first, then we add it to another integer c, it is actually equal to the second and third integer added first, then 2 added to first integer. Okay, that is 1 plus 3 plus 7, that is equal to 4 plus 7 is equal to 11. That is actually equal to 1 plus 3 plus 7. So 1 plus 10 is equal to 11. So these two are same. Okay. So the multiplicative counterpart for the associative property, what it tells us is if we multiply two numbers first and then multiply it with the third number, that is actually equal to the second and third number multiplied first and then multiplied with the first number. So here you can see that 3 into 4 into 2 is equal to what? This is equal to 12, that is into 2 is equal to 24. And here you can see that 3 into 4 into 2, that is equal to 3 into 8 is equal to 24. Okay. Then we saw that the identity element for addition. Okay. So it was 0. Why it is not 1? Because 3 plus 1 is not equal to 3, right? And how 0 is not a multiplicative identity? As 3 into 0 is not equal to 3. If we multiply any element a into 0, we can't say it is equal to a, right? So that's why 0 is not a multiplicative identity. Okay, that is 0 is not a multiplicative identity. 1 is a multiplicative identity. And here you can see that a plus 1 is not equal to a. Okay, so that's why we say that 1 is not a additive identity. Okay, so the additive inverse element of integers. Okay, see, so what we saw there, if a is an integer and minus a is also an integer, then we say that if their addition is equal to 0, then we say that a is an additive inverse of 0. So the fifth property tells us that the inverse element of addition, that is if a is an integer, then so the fifth property of integer tells us about the inverse element of addition. Okay, if a is an integer, then minus a is an additive inverse of A. Okay, why? Because A plus minus A is equal to 0. We saw that for 1 it is minus 1, that is equal to 0. For 2 we saw that minus 2 is its additive inverse. That's why their sum is equal to 0. Okay, their sum is equal to 0. That's fine. And we can see it for all the natural numbers present in the integer set. Okay, and you can also say that what is the additive inverse of minus 1. So additive inverse of minus 1 is actually 1. Okay, because minus 1 plus 1 is equal to 0. Okay, so the inverse element of multiplication, if we have uh, so the multiplicative inverse of a non-zero integer. Okay, here a point is to be noted that the multiplicative inverse of a non-zero integer a is 1 by a. So we can't get a multiplicative inverse of 0. Okay, 0 is something for which we can't get a multiplicative inverse. So for only non-zero elements, we can get its inverse multiplicative inverse. Okay, for 1 it will be 1 by 1, for 2 it will be 1 by 2, for 3 it will be 1 by 3, for minus 7 it will be minus 1 by 7. Okay, so for a it will be 1 by a, given that a is not 0. Okay, and you can see that 1 into 1 by 1 is equal to 1, 2 into 1 by 2 is equal to 2, 3 into 1 by 3 is equal to 3, and so on. That's why we can actually evaluate for each integer its multiplicative inverse except the 0. Okay, for 0 it is not allowed that we take its inverse, multiplicative inverse. Okay, so the sixth property was distributive property. Okay, that is, if we have three elements and the first element is multiplied with the sum of the second and third element, that is actually equal to the multiplication of first and second element and added to the multiplication of first and third element. So here we got 1 into 2 plus 3 and 1 into 5 is equal to 5. And then we saw that it is actually equal to 1 into 2 plus 1 into 3, that is equal to 2 plus 3 is equal to 5. These two numbers were same. Okay, so we can say that the distributive property holds. And we took another example and saw that it is also same in this case. Okay, students, that's all for now. Thank you.